In January 2020, scientists detected something they had never seen before: a black hole swallowing a neutron star whole. No debris, no light, just one cosmic monster devouring another in a single bite. This was the first confirmed black hole neutron star merger in history. Right now, somewhere within 1 billion light-years of Earth, a black hole is merging with a neutron star. It happens at least once a month. And Einstein himself said we would never be able to measure it. Two of the most extreme objects in the universe, locked in a deadly spiral. One devours the other, and in that moment, gold is forged, space-time trembles, and everything we thought we knew gets rewritten. This is their story, deep in the universe. Thankfully, very, very far away from us, some truly bizarre things are happening. We know about black holes. We have talked about them plenty. Those dark giants we can never quite fully understand. While we sit here discussing them, they are pulling everything that dares approach their event horizon into the unknown, spinning everything around them at nearly the speed of light. And then there are neutron stars. You could call them black holes that didn't quite make the cut. But we can understand them a bit better. After a bright star that once lit up and warmed everything around it dies, it collapses in on itself, leaving behind almost nothing but neutrons, the densest things we can actually see and touch. Each one of them, on its own, is an object that pushes the very limits of what our minds can grasp. And somewhere in the depths of the universe, sometimes these two get dangerously close to each other. What do you think happens when these titans meet? You will not have to think too hard to figure out the answer. Say goodbye to the neutron star. Fortunately, we do not even need to guess. We know exactly what happens when a black hole meets a neutron star, and we know exactly how this nasty encounter plays out. January 2020 was an incredible month for the world of science. Of course, back then we had no idea the pandemic was about to arrive. That month, scientists at 2 observatories called LIGO and Virgo, designed to detect gravitational waves, picked up not 1, but 2 merger signals. In both separate events, a black hole had come face to face with a neutron star. And in a way, this completed every possible combination involving these 2 objects. Scientists had already detected 2 black holes colliding and 2 neutron stars colliding. Now, the final pair had been found. In fact, the LIGO-Virgo collaboration had already caught some signals resembling this type of collision back in 2019. But due to certain uncertainties, no definitive conclusion could be drawn. But now it was certain. Black holes that swallow neutron stars were real. Of course, this was not an incredible surprise or something completely unexpected, but now we finally had proof. And LIGO researcher Zuzia Marca, who worked on the study, put it simply: this is the event we can point to as our evidence. Let us take a closer look at the collisions that were discovered. These 2 events happened in completely different and distant corners of the universe, totally independent of each other. The first one, detected on January 5th, involved a black hole 9 times the mass of our Sun and a neutron star about twice the mass of the Sun. In the other event, detected on January 15th, a black hole with 5.7 solar masses and a neutron star with 1.5 solar masses were involved. Based on 2 separate events happening so close together in time, Scientists estimated that within 1 billion light-years of our solar system, at least one of these mergers happens every single month. Maybe even more. Way more. Like I said at the beginning, just think about what is happening across even greater distances while you watch this. Even the idea that we can somehow witness these events with our own eyes feels strange. But let us get to why this matters. If Einstein came to mind, you are right. He predicted this. At the very least, he said this: the movement of extremely massive objects through space-time could create gravitational waves. He also made another prediction, by the way, that we would never be able to measure them. And unfortunately, until 2015, he seemed to be right. Nobody had even attempted to detect these ripples in the invisible fabric of space-time. But in 2015, an observatory called LIGO, which had just begun operations and was designed specifically to catch these waves, detected gravitational waves from two colliding black holes for the very first time. After that, LIGO was upgraded even further, and two more observatories joined the search: Virgo in Italy and KAGRA. It was not long before more black hole collisions were detected, and right after that, the collision of two neutron stars. The basic principle behind these observatories relies on two separate arms. Inside those arms, there are mechanisms that vibrate ever so slightly when gravitational waves pass through. In the 2020 detections, those vibrations were different from anything seen before. So scientists even had a name for these signals. They called them chirps. And this time they said it chirped differently. For one thing, the signal fell outside the expected range for either type of object. If it were a neutron star, it would have been the most massive one ever observed. If it were a black hole, it would have been impossibly light. On the other hand, to verify these events, scientists also searched for the electromagnetic radiation that such collisions would normally produce. Under typical circumstances, there should have been some, but this time there was nothing. No other clue whatsoever. This was, without question, a neutron star and black hole merger. But this absence of light had another meaning. Before this detection, scientists were not entirely sure what would happen in this kind of event. Would the much more massive black hole swallow the neutron star in one bite, like Pac-Man? Or would the neutron star be torn apart before reaching the event horizon, its remains sucked into the black hole like a cosmic tornado? If that were the case, the result would be incredibly high temperatures, and with powerful enough telescopes, we could actually observe the event. But the fact that neither event produced any electromagnetic signal meant only one thing. The black holes really did swallow the neutron star's whole in a single bite. Just picture that for a moment. Before we move on, is that not absolutely wild? And discoveries like these can teach us some incredibly important things. First of all, how does a pair like this even come together? Maybe both of them were born as stars in the same system. Or maybe later, inside one of those dense star clusters packed with countless stars, they drifted into each other's orbit at some point. Then, in an order we cannot be sure of, both stars died. One became a black hole. The other became a neutron star. And their story ended with one devouring the other. But these discoveries can teach us something else entirely. How does our universe contain so much gold, platinum, uranium, and other heavy elements? Nearly half of all elements heavier than iron are created in collisions like these, and in explosions like supernova. And the frequency of black hole and neutron star mergers discovered in this study could reveal just how much of the universe's heavy elements come from events like these. Right now, scientists are upgrading the LIGO and Virgo detectors even further. They are expected to resume observations this year in June, and KAGR in Japan will also join the effort. With these upgrades, the detectors will be able to pinpoint exactly where in space these events are happening. That means astronomers can aim their telescopes with much greater precision. One thing we can say for sure: everything we have seen so far is just the tip of the iceberg. Far more exciting discoveries are waiting for us. These ongoing studies, new discoveries coming from the James Webb Space Telescope? I honestly do not know, but our generation might just witness revolutions that completely rewrite what humanity knows about the universe. What do you think? And as always, until we meet again, I am glad you are here. Take care.